You're given the quadratic equation x squared plus x minus a equals 0. If the constant a is between 0 and 200, what is the greatest possible integer solution to this equation? Pause the video to give it some thought, and when you're ready, join me for the solution. Let's start by using the quadratic formula to get a handle on the form of the solution we're looking for. Substituting 1 for a, 1 for b, and negative a for c, we get the following expression. To get the greatest integer solution, we need to make the square root of 1 plus 4a as big as possible and ensure that it's an integer. Since maximizing 1 plus 4a will also maximize its square root, we'll only need to look at 1 plus 4a and set it equal to a perfect square, which I'll represent by k squared. Since a is between 0 and 200, we should start with the highest value for a as possible. If a is 200, then we're looking for a perfect square around 800. 30 squared is 900, but that's too high. So let's try 29 squared. That's 841, also too high. How about 28 squared? 784? Yeah, that's a good starting point. To make it more efficient to test these perfect squares, let's rearrange the equation as a difference of two squares. Now, let's put 28 in for k. That will give us 4a equals 29 times 27. And that won't work because neither of those numbers are divisible by 4. Okay, how about k equals 27? That will give us 28 times 26. That looks good. 28 is divisible by 4, and when we solve for a, we get 182, which is less than 200. Now let's take that value for a and plug it into our equation to solve for x. Let's prime factorize 182 to get a handle on some potential factors. 2 times 7 is 14, and that will pair with the 13 perfectly to allow us to factor the equation. So our solutions are x equals negative 14 and x equals 13. Since 13 is the greater of the two, that's our answer. Congratulations if you got this correct. Let me know in the comments if you got x equals 13 and if you solved it using a different approach. Thanks for watching and see you soon.